Trish Donahue is a senior pollution prevention engineer and program manager. Trish provides technical assistance to businesses, including manufacturing process assessment, supply chain optimization, material and energy balances, and evaluation of environmentally preferable and cost-effective alternatives. Our second presenter today is Tom Ruley. He provides technical assistance that includes assessing manufacturing processes, performing and demonstrating Lean Six Sigma practices, and discovering solutions that result in environmental impact reduction across industry. And last but not least, we have Dave Pfister, a senior pollution prevention engineer who provides technical support, water optimization, and food processing, water purification, water recovery, metal plating, powder coating, and parts cleaning. Additionally, he assists companies with evaluation of methods of improving water use and energy recovery and optimization. Before we jump into the material for today's webinar, I want to go over a few logistical items with you. First, a recorded version of this webinar will be available afterwards. This recording will be sent to anyone who has registered. We will also post the recording on our website. This webinar should last for approximately 45 minutes. We would love to hear from you during this session, so please use the chat feature to ask any questions. We've left off about 10 minutes at the end of the webinar to answer those questions. Any questions we are unable to get to, we will follow up with a summary. I will now turn it over to Trish.
Good afternoon. Thanks, Mark. We hope you'll be inspired by today's topic, Best Practices for Sustainable Manufacturing, which are based on 4 projects conducted in the southern tier of New York State. Today's agenda will cover these topics, starting with an introduction to the New York State Pollution Prevention Institute, or P2I for short. Then we will quickly discuss the funding that made the 4 projects possible. A high-level overview of the 4 projects will be provided, but the greater focus will be on how you may be able to make your manufacturing operations more sustainable using a simplified DMAIC process. And as Mark mentioned, we will wrap up with Q&A. So a little bit about P2I. We are currently in our 11th year serving New York State businesses and communities. We are headquartered at Rochester Institute of Technology, a large private university in Rochester, New York. We are in partnership with 4 other universities, including Clarkson, Rensselaer Polytechnic Institute, Cornell, and Binghamton University. Together, we achieve our mission of assessing organizations to reduce their environmental impacts, such as waste reduction, water and chemical use reduction, and creating a more sustainable supply chain. P2I is funded by the New York State Department of Environmental Conservation through the state's Environmental Protection Fund, but we also seek funding to support special projects, and in this case, the Environmental Protection Agency awarded P2I with a Source Reduction Assistance Grant to support environmental impact reductions and sustainability in the southern tier due to the region's economic and environmental status. This grant of nearly $90,000 was added to our funding from the DEC to enable P2I to conduct assessments at 4 manufacturing companies, identify improvement opportunities, and assist with implementation of our solutions. Our solutions involve pollution prevention, including reduction, reclaim, reuse, and recycling. So these are the 4 companies that were selected in the southern tier to receive assistance from P2I through this grant. Each company had different project goals to reduce their environmental impact, and each project utilized the DMAIC process for identifying the challenge or problem, finding potential solutions, and implementing a solution to gain results. Tom will provide further details on DMAIC next and how you may be able to use the same high-level approach in your organization to make process improvements. But first, let's dive into each of these projects a little further, from left to right. C.H. Thompson and Triple Cities Metal Finishing are both metal finishers who were using high quantities of water in their many plating rinse baths. These baths also contain chemicals that must be removed through wastewater treatment before discharging to a municipality. By measuring and analyzing data provided by these companies, P2I identified that simple properties such as pH and total dissolved solids could be monitored to control the flow of water in rinse baths. By implementing chemical analysis, water flow controls, creating operating procedures, and training personnel, together these companies have the potential to save greater than 5.5 million gallons of water per year and annual cost savings of $35,000, plus any other savings associated with reducing chemical use and associated wastewater treatment. Next, another company selected was an auto parts manufacturer whose project goal was to reduce high volumes of a costly liquid waste during an equipment cleaning event. These events happen a couple of times a year, and P2I observed the process steps taken during the cleaning event to understand how the waste was generated and what was the root cause of the high volume. After defining the process, P2I once again looked at the physical properties of the waste stream, including temperature and solubility of the contaminant being cleaned from the equipment. P2I identified that increasing the temperature of the water used for cleaning and agitating the water, that it would increase the solubility of the contaminant. This would then decrease the amount of water needed to complete the cleaning. So by using less water, the volume of hazardous waste is decreased. Also, it was identified that the contaminant itself can be reclaimed from the cleaning water through equipment technology. The benefit of this reclaimed contaminant is that it can be reused in the company's product manufacturing. By implementing these solutions, the auto parts manufacturer has the potential to reduce the amount of hazardous waste by 50,000 pounds per cleaning event and reclaim 32% of the contaminant material. With the reduced hazardous waste quantities and the cost avoidance achieved through reclaiming and reusing the material, the company has the potential to save $50,000 per event. Next, the fourth company was Kick Custom Products. They are a personal care products manufacturer, and Kick was also experiencing high volumes of waste generated during equipment cleaning. This waste, however, consisted of Kick's final product. Water is used for cleaning the product from equipment, but this water has already been through a costly purification process in order to be used in the manufacturing equipment. After creating a process input-output diagram to determine all of the areas where the waste was being generated, P2I once again looked at the properties of the waste, such as temperature and viscosity or thickness of the products. The team calculated the total cost of ownership, or TCO, of the waste, including the disposal costs, lost product revenue, labor, and the initial water purification. And together that was approximately $1.5 million per year. By focusing on the temperature of the final product and increasing its flow through the equipment, Kick has the potential to recover 60% by weight of the waste that could otherwise be valuable product used for sale to customers. Purified water used for cleaning would be reduced, resulting in less overall waste generated, and ultimately, waste disposal costs have the potential to be reduced by 66% per year. As mentioned, P2I conducted these projects using the DMAIC approach to make process improvements, and I'll now turn it over to Tom to discuss what DMAIC is and how it can be used for your organizational environmental improvement projects. Tom?
P2I utilized the Six Sigma methodology called DMAIC to improve the environmental impact identified in the 4 selected projects. DMAIC stands for Define, Measure, Analyze, Improve, and Control. In the Define stage, the team will ask, why is this project needed? What is the problem or challenge? What are the goals? How will success be measured? In the measure phase, baseline data or the current state will be collected or measured. In the analyze phase, you will research ways to improve the current state in order to reach goals. In the improve phase, the testing and implementation will be executed. In the final stage, which is control, data collection will continue and monitoring of the process will also continue. The defined phase comes down to simply, why are we doing this project? There could be multiple reasons that a company would want to consider addressing environmental impacts. Some of these reasons you may ask include, is our company incurring regulated or high operating costs? Is it required for a certification? Are we a part of a company-wide initiative? Is it due to competition or customer requirements? Are we trying to increase product yield? Understanding why the project is being conducted will help derive goals and objectives for achieving the project. Challenges tend to be broad statements. After identifying a challenge, creating specific goals and objectives are critical in order to define the pathway and how to measure success. Below are examples of goals and objectives for sustainability initiatives. Notice how the goal is general and the objective provides specifics that can be measured and assessed to determine the success of a project.
The next stage in the process is to measure. What is the current state of the process? So once the goals and objectives have been defined, the current state needs data. Historical data is very valuable because it provides long-term information. Data such as water bills, waste hauler bills, hazardous waste manifests are all extremely valuable in determining amounts and costs of waste. Beyond historical data is the data that must be measured. Here's an example of some baseline data from one of our case studies, which is historical data. In this case, hazardous waste. On the left, at the bottom, is a waste manifest, which defines what the waste is, why it is hazardous, and the amount. On the right side is a summary of the waste cost structure, which is extremely important to decide where costs are being incurred and how much the costs are. So the next step after getting some of the historical data is to look at the process details. Some processes may have meters or gauges to measure more detailed data, such as water meters or waste bin counts, waste costs from the hauler based on volumes. Some of it will still need to be measured. An example using one of our case studies is the process detail map showing waste generation locations. The first table shows the waste locations and the amounts in Pareto form. The second table shows the dollar values associated with the product lost to waste. The right-hand side shows the actual process details to show where waste is being generated and therefore where improvements need to be made.
What does your team do with all the data collected? In waste reduction projects, the first step is to analyze the waste material and the process changes that may be required to avoid waste. Process changes may not reduce the waste, and being able to assess alternative technologies to reduce, reuse, or recycle material may be needed. This can be an important component to evaluating technology. top left shows the steps to analyze data, which includes the materials, properties, process changes, and alternative technologies. While a chronological flow is presented for assessing waste reduction, steps can be taken in parallel or a staggered approach. To the right, you can see the EPA waste management hierarchy. As process changes and technologies are reviewed, it is vital to keep in mind that source reduction and reuse are the most preferred waste management practices. The first step is starting with the understanding the materials and the properties as they go through the process. This is fundamental knowledge that, along with understanding the manufacturing process, will identify changes that can be made to the process and reviewing alternative technologies. You may ask, why would we analyze or material or process changes occur before assessing alternative technology? A majority of the time, process changes will require less cost than the purchase of capital equipment and then the validation of that equipment. Reviewing what can currently be done with the resources and equipment available is a great first step and may not require diving into alternative technologies. The final piece is payback. Sustainability initiatives include feasible solutions for the company. If too costly or too labor intensive, the initiative will fail due to a lack of support. The assessment example shown here includes testing the materials and their properties, assessing technologies, and then calculating a payback. This example presented shows how P2I tested the solubility of a waste stream, which includes a byproduct of a manufacturing process. This waste stream required hazardous waste handling, contained between 40 to 60% recoverable material, and was very difficult to remove from processing tanks. P2I conducted solubility tests and reviewed SDS sheets in order to understand the endothermic and solubility properties. The team plotted the temperatures of the cleaning water on the solubility curve and found a 50-degree gap in the current temperature of the cleaning water to what is needed in order to dissolve the material. The technology that could be implemented would be immersion heaters and agitators that would have a payback of about 5 months and mostly saved on labor costs. However, this did not address a major cost of lost raw material and hazardous waste disposal. The ultimate solution was a photo on the right, which separated out the good and bad material. The ability to recover material for reuse, reduce hazardous waste costs, and reduce labor time allowed for a payback of under 18 months.
The next step, once baseline data has been found, technologies have been found, improvements have been found, is the actual implementation or improvement step. The next part after doing the improvement step is actually the method to maintain the improvement change. Shown is a small segment of a plating line from one of the projects. Simple monitoring of pH, connectivity, and flow were used to determine whether plating line rinses were working properly or not. In this segment of the plating line, the proper use of cascade rinse tanks reduces water use from 4 gallons to 2 gallons per minute. Counterflowing the cascade rinse allows reuse of the rinse water for an additional reduction of 2 gallons per minute. The plating line rinse water reduction was relatively easy to implement. However, control of this process change was not as easy. It depended on operators understanding that the rinse flows needed to be set to a given value rather than just turning the rinses on. The control plan included signage, procedure training, and daily monitoring of flow rates.
So while we realize the project examples we provided today are not exactly the same as your processes and activities, we hope that we've provided you with an approach to problem solving that ultimately reduces an environmental impact challenge that you may be facing. In summary, the DMAIC process is an effective tool for problem solving that gets to the root of the problem and keeps the project focused. You know that you have a challenge or a problem in your operations. So the 4 big takeaways from our presentation include defining your project sustainability goals and objectives. And certainly you have a lot of information and data available about the operation and activities. It's just a matter of collecting and using the information for this specific purpose. Baseline data is more readily available than perceived. Rather than thinking of a different way to treat or get rid of your waste, focus on pollution prevention, including reclaiming, reusing, and recycling. But primarily, analyze with source reduction as the #1 goal for reducing waste. And finally, continue to monitor and control your improvements by creating consistent operating procedures, training your personnel, and periodically reviewing data to ensure you are staying on track. So we welcome you to visit P2I at the link that you see on your screen. And if you're interested in these project case studies or others, please visit the case study page on our site. We thank you for taking the time to join us today and hope the examples and the approach we shared will enable you to make your manufacturing operations more sustainable. And with that, I'll turn it back to Mark for any questions that you all may have.
Thank you very much, Trish. So it looks like a few questions did roll in during the webinar. As a reminder, if you have any questions at all, please feel free to use the chat feature, and we will take the time now to answer those. So the first question that came in for the team is, did your assumptions of where waste was produced in a process hold true after the process mapping exercise?
So in some cases, absolutely. Companies had a fantastic handle on understanding where waste was produced. There were a couple examples, however, where after process mapping and actually measuring where waste was coming from, we identified other areas of the manufacturing line that were causing high levels of waste, which was an eye-opener for a lot of these companies. And then tying that back into source reduction, trying to reduce those areas so you don't see the impacts downstream.
And I think that's really important where data comes into play. So once we had mapped out the process itself with all the stages and steps of the process, we were able to look at how much of a waste, for example, was generated in each of those steps. And in a couple of cases, the company themselves, they had made some assumptions that the higher waste was generated in certain activities, but in looking at the data, we were able to see that it truly was coming from other areas that they hadn't necessarily suspected. And by taking that data and Paretoing it out, we were able to see which of those areas had the highest, and we could focus our attention on making recommendations or trying to understand solutions to those high potential areas.
Great, thanks Trish and Tom. This next question's a two-parter. What if data isn't present or available, and how do you go about procuring or mining the data?
So a great first step is talking to accounting and finance. A lot of invoices and waste manifests will come through there, and they will have these line items for waste disposal, your electric bills, water bills, etc. That's a great starting point. That doesn't require purchasing any equipment to measure or anything like that. The next key piece is if you can't identify it with your accounting and finance team, it may be worth calling up your service providers and asking them a few questions. One thing we have found with working with some of the waste service providers, waste management, they can also help provide sustainability solutions as well. And it's definitely worth asking them those questions. The final piece is you may not have easy access to all this data, or you may need to granularize it even more, specifically with how much water you're using within a process. So you may have to go buy flow meters, etc., to be able to measure that and map them out and place them in the ideal locations.
Yeah, and we also do mass balance, so we can see how much product or material, ingredients, parts are going into each step of the process and understand how much is coming out at the end. That's why we do a process input-output diagram, so we can understand all of the flows that are going in and everything that's coming out, do a material balance. We take a look at how well each of those numbers make sense. Sometimes it's really just looking at it to be sure that that it's reasonable and that it truly is making sense, as opposed to just making some assumptions.
Great, thank you. Looks like we had another question come in. How do you approach a project when you have an unfamiliar process?
I'll take that one. The idea with going into a process is we recognize that it is a process for starters. The whole idea is there are, as Trish said, inputs and outputs. There are steps taken at each phase of a process. There are wastes generated at each process. Maybe it might be as simple as scrap, but the whole idea is it is an A to B to C to D type of an operation. So we'll go in and try to understand what that process is. Now, we actually may have a slight advantage in some cases because we're looking at it with a new set of eyes. But the reality is there's times when we really need a lot of help from the people actually running the process to say, okay, what are you actually doing in these different steps? But the bottom line is you are able to now look at a process and say, I understand where everything is happening and why it's happening and where the waste is being generated or scrap is being generated.
Great, thank you, Dave. And it looks like we just have one more question. How do you avoid scope creep with sustainability projects and keep everyone informed?
So I'm sure everyone in the audience knows this, and they conduct status meetings and they're tracking all the tasks and objectives and making sure they align with the goals. And that's always the key with any project that you're doing, making sure that what you're doing is meeting objectives and goals for that project and is within scope. A really big key, though, that sometimes is missed is making sure that any key stakeholders or project sponsors are well informed in the whole information management piece of that. Projects, if a project is hitting a few snags because certain groups aren't pulling their weight, or you need help in other areas, project sponsors may be able to go up to the higher levels and ask for a little bit more support, and also they can continue to inform them, and the whole project will still have momentum. When the higher levels of an organization don't understand the project or what the value of it is, then that's when you can run into issues where the project starts to fail and starts to kind of fall apart.
Yeah, I just want to reemphasize that these projects that we go into always take a look at cost of this problem to begin with. What is it costing the company? Why is the waste itself really costly? Is the wastewater treatment really costly? So taking a look at those costs and then trying to find a solution that will alleviate those costs and to do a payback. But first of all, we needed to have buy-in from the decision makers. And with any company, the bottom line and the cost overall is what really is the impetus to doing projects and making those changes. So by just understanding and talking to the right people and being able to provide those financial costs and benefits of what the solution is, and speaking the language of the business and the decision makers, then you'll be able to get that buy-in and make those changes quicker. Again, it's just really focusing on the costs and the impacts of the business.
Thank you very much. And it looks like that was the last question for this webinar. Again, I want to thank everyone for joining us today. And as we shared some of the best practices for sustainable manufacturing. As I mentioned in the beginning, you will be receiving a recording of this webinar, and we will be posting it on our website. If there's any questions that you think of after the fact, please don't hesitate to reach out to us via phone or on the email that's on the screen there. Again, thank you for taking time out of your day to join us on this webinar.